Oh yeah. Still don't know what I was waiting for, and my time.
This is the swordtail kerasin. This one lives in a stream high in the mountains of Trinidad. It likes to eat small beetle larvae. Let's call this stream the beetle stream. As conditions in the environment change, groups of kerasin become isolated in different river systems. Now we have two populations of kerasin, one in the beetle stream and another in an adjacent one. In the adjacent stream things are quite different. The beetle larvae are hard to come by. This stream, however, is much wider and therefore has many more branches and leaves that overhang the water. The branches and leaves that overhang the stream are covered with ants. These ants fall into the stream and now present the main source of food for the kerasid. Let's call this stream the ant stream. Now, let's take a closer look at the kerasins. These fish are sexually dimorphic. Sexual dimorphism is the difference between the male and female of a species. Just look at humans. Men have things women don't have, and vice versa. Well, in the case of the kerasins, the male has a small bean-shaped object attached to its gills by a thin thread. And as with all species, variation exists between the males. Just take a look at all the different sizes and shapes of, let's say, the human male's ear. Some are big, some are small, some simple, some intricate. Now, the human female doesn't choose to mate with the male, solely based on the shape of his ears. Most of the time. The female kerasins, on the other hand, don't choose to mate at all. The male, driven by instincts beneficial to the survival of his species, insert a packet of semen into the unsuspecting female, who keeps it until she has eggs to fertilize. She can use the same packet for numerous batches of eggs. This would be a difficult task to complete. Sneaking up on the female, getting in the correct position, then injecting the packet, all in the split second. The majority of males would fail, therefore never passing on their genes. Let's go back to the first of our two streams, the beetle stream. Here, some of the males have a fat, oval-shaped appendage and a few hungry females often mistake this for a beetle larvae. This error of judgment puts the female into the ideal position to be instinctually inseminated with the package by the male. Having this advantage, these males, obviously, pass on more genes to the next generation. Those without the fat, oval appendage die out and over time are replaced by males with the biggest, fattest, most beetle larvae-looking appendage. Over in the ant stream, the kerasins that quickly recognize the ants as potential food have become more successful, and therefore common. They sometimes mistake non-ant objects as food, but that is okay, no harm done. One particular male in the ant stream has an appendage of a thin irregular shape. This is enough to confuse a few females into thinking it's an ant. Just long enough for him to instinctually inseminate her. As you would expect, this male produces many more offspring, all of which carry the gene to make them irregular appendages. In the beetle stream, on the other hand, the fat round appendages are an advantage, giving two distinct forms from one common ancestor. This process is known as sexual selection. Charles Darwin covered the subject briefly in Chapter 4 of The Origin of Species in 1859, and more thoroughly in his 1871 publication, Descent of Man and Selection in Relation to Sex. Sexual selection works differently from natural selection. It works for the development of variation leading to speciation, rather than weeding out the unsuitable, as in natural selection. The swordtail kerasin example in this video is based on the research carried out by Nicholas Combe and his team. Published online on the 12th of July 2012 at currentscience.com. The research shows the power and speed of sexual selection on a species. Thank you for watching, and please take the time to sit and think of all the intricate factors that make this world such an amazing one.